In this lecture, we will learn about matched and reciprocal properties of a network. Networks have three important properties which are considered during design and analysis for a microwave network. Those are matched, reciprocal, and lossless. Consider a three-port network as shown here. Based on the generalized S-matrix equations learned in the previous session, we can write a three-port S-matrix as shown here. The network shown here is called a power divider or a power combiner. Based on the direction of how we feed power, it can be a power combiner or a power divider. In the first case, the three-port network is a power combiner, while in the second case, the three-port network is a power divider. Okay, so getting back to the three properties, we know what is a matched network already. Matched implies that each port of the device should be matched to the impedance of the connected device. In most cases, it is a transmission line that connects devices which has a characteristic impedance of Z0. Let us consider this with an example. The power divider or combiner that we saw in the previous slide is an example of a three-port network with an S matrix as shown here. The numbers 1, 2 and 3 represent the three ports of this power divider or the power combiner. Say I am measuring the S parameter S11 which is at port 1. This means that when looking into the device at port 1 and measuring two voltages V1 minus and V1 plus, the condition is that the port 2 and port 3 should be terminated with matched loads. That means when measuring S11, V2 plus should be 0 and V3 plus should also be equal to 0. This means that the port 2 and port 3 should be terminated with matched loads. This means the ports are matched to Z0. Similarly, for other two ports, which we get values of S22 and S33. So to generalize, matched means no reflected wave. Thus, when port 1 is matched, then V1 minus is 0, which means S11 is 0. Similarly, when S22 is matched, that means V2 minus is 0, which means S22 is equal to 0. Similarly, when port 3 is matched, it means V3 minus is 0, which means S33 is equal to 0. This means that all the incident energy on any of these ports is absorbed by the network and nothing reflects. Thus, a perfectly matched network has all the ports matched, and thus the S matrix now simplifies to this, where all the diagonal elements of the matrix are 0. Reciprocal network. Okay, so let us look into the reciprocal property. Reciprocity is a natural property of materials used to build microwave devices. Unless we intentionally design non-reciprocal devices like amplifiers or use ferrite materials, most other materials are reciprocal. Reciprocal implies you can interchange one port with another and get the same operation from the device. That means you can interchange what you call an input port as output port and an output port as an input port. Thus, in our three-port network shown here, it can act as either a power combiner or a power divider because the ports are reciprocal. Thus, the general definition in S parameters language is that Sij is equal to Sji. Thus, the matrix now simplifies to following, where S21 is now written as S12 and S31 is written as S13 and S32 is written as S23.